We're on the deck of the Coastal Institute at the Graduate School of Oceanography, speaking to Peter Cornillon, who's a professor here at GSO. Peter is also a member of the Flow Rate Technical Group, which has been called in by the government to look into the British petroleum spill in the Gulf of Mexico. Peter, the public has by now been stupefied by the videos of the pipe spewing oil underwater. How can scientists look at that and tell how much oil is really going into the water?
There are a number of different ways, a number of different methods that were used to estimate the flow rate. The first one and the early estimates were made with satellite-based aircraft and then satellite-based estimates. And that's where they look at the surface of the ocean and they look at the area covered by the spill, and then they estimate how thick the spill is at different points in the surface, and from that they get a volume on the surface. They then estimate how much is entrained into the water columns under the surface, how much is burned off, how much has been picked up. So that was one set of estimates, and the early ones, as I said, were aircraft followed by satellites. The reason they had to go from aircraft to satellites is the region covered by the spill increased to the point where aircraft weren't really viable. A second method used is to look at videos of the flow coming out of the tubes, and there they use what's called a particle image velocimetry. It's actually a altered version of particle image velocimetry. The way particle image velocimetry, or PIV, works is you seed the water with little glass balls. They're 10 microns, teeny, teeny, teeny. You can't see them, and you put millions of them in the water. And then you look and you take videos of the flow and look at how the glass balls move from one frame to the next. In this particular example or case, what we did is we take the oil that's coming out of the pipe, and there are structures in that oil due to the turbulence, and we followed those structures. And you can then calculate the velocity. If you know where the structure is in one frame, and then you look at the next frame, you can see how far it's moved, how many pixels it's moved, and from that you can estimate a velocity. And then if you know the area of the plume, you can get a total volume. There were three other methods that were used to estimate the flow. Another one was to look at the shape of the plume, and because it's a turbulent plume, you can learn from the shape approximately what the flow rate was. A fourth method is to look at the pressure at the bottom of the well, pressure at the surface of the well, and then to make some assumptions about the flow that you would have from that. And the final one was when they stuck a pipe inside and started sucking oil out. That gave them a volume estimate of what they were sucking out, so they knew it had to be bigger than that.
Peter, everybody's been looking at the same video, so why is it so hard to get a hard number on exactly how much is coming out of that pipe?
One of the things is if you look at the videos, what you'll see is that in the space of 30 seconds to a minute, you'll go from half or more of the flow coming out of the end of the tube being a clear jet of methane, and the other less than half being oil, to all of it being oil. And it varies over very short periods of time, and at the same rate that fraction is varying, the actual amount of fluid coming out is varying. The second problem is that it's very hard to make these video estimates right where the oil is coming out of the pipe, so you have to make it some distance away, a foot or 2 feet away. And when you go that distance, the oil that goes from the exit of the pipe to that point is entraining water along with it. And so you don't know how much water is being measured. Also, the oil plume is dark, it's black, you can't see into it. So all of the estimates of speed that are made are based on the outer edge of the plume, and you have to assume that inside the plume the fluid's going at about the same rate. Not an unreasonable assumption, but there's uncertainty associated with that.
Well, as this has gone along, we're getting conflicting reports of the amount of oil actually going into the water. Really, whose numbers are the President and the general public supposed to be looking at and to believe?
When you say there are conflicting reports, What do you mean? There's numbers coming from different places?
We're getting, yes, different numbers from British Petroleum than we are, say, from the Coast Guard's Tad Allen. And we're hearing even things coming out of the flow rate technical group that have varied a little bit, possibly because you're learning more as we go on.
Right. I would go with the flow rate technical group. I mean, all the different pieces of information have been brought together, and the flow rate technical group, reports to actually NOAA. It was formed by NOAA and is being run by Marcia McNutt, who is the head of USGS, and that's where all this information is to be consolidated.
What would happen if all of a sudden this oil source just dried up and we saw nothing coming out of the pipe?
Well, we already have a real lot of oil in the water column, and that oil is going to drip somewhere, and I guess we don't know how much oil is in the water column. We don't know where it is. The oil on the surface is going to continue to drift around, and my guess is it's going to continue going into the marshes and other areas and cause a fair amount of damage there, or a lot of ecological damage. But I think it's the subsurface stuff that's the real question mark. We really don't know how much there is subsurface, what form it's in, how toxic it'll be, depending on how much it's been distributed in the water column. So I think there'd be damage for a while to go.
Well, I think we've got a lot of boggled minds out there for any number of reasons. So thank you very much, Peter.
Yep, my pleasure. Thank you, Chip.